Hi secondary 2, I hope you are okay. We will complete what we have discussed before. The last record we have discussed the thin prism, and the minimum angle of deviation in the thin prism is equate to the apex angle by the refractive index -1. From that we have to know that the thin prism dispersed the white light into 7 colors, which we have known in preparatory stage as Roy above, starting from the red till violet. You have to know that there is angle of dispersion. The angle is between the minimum angle of deviation of the red radiation and the minimum angle of deviation of the blue radiation, and you have to know by making a difference between the minimum angle of deviation of the blue minus the minimum angle of deviation of the red. We will get apex angle, refractive index of the blue color -1 minus apex angle between bracket by the refractive index of the red -1, which we will get apex angle as uncommon. So between bracket we will have refractive index of the blue minus refractive index of the red. It's called an angle of dispersion or dispersion angle. And you have to know also that we have dispersive power, which is the ratio between the angle of dispersion between the blue and red and the minimum angle of deviation of the yellow. Omega node is a symbol of dispersive power, which is equal to alpha node of the blue minus alpha node of the red, which is the dispersive angle or angle of dispersion, over alpha node of the yellow. So by taking the common factor apex angle here and here, substituting them, so the final law will be refractive index of the blue minus refractive index of the red rated to refractive index of the yellow -1. You have to know to get the refractive index of the yellow, you have to make an average. It's an average of the blue color deviation angle and the red color deviation angle. So if you want to get the deviation angle of the yellow, you will make a summation. You have to know also that the refractive index of the yellow will equal to the refractive index of the blue plus the refractive index of the red over 2, because it's an average for both of them. Here is a thin prism and the light lesson is ended, so we will start to talk about the hydrodynamics. Hydro is from water, so liquid, so fluid. Hydrodynamic is motion, so it's motion of the fluid. It has two types, it's a steady type and a turbulent type. Steady is the flow of liquid with a small viscosity, with a small velocity or the small viscosity, Sphelon's velocity. You have to know it's a very small velocity, and the layers slide over each other as the water pass in a small velocity. It will get a steady as a Nile River. You have to know as a Nile River is called a steady flow. But if we are talking about the turbulent flow, it's about the waves of the seas, so the fluid of the liquid and its velocity exceed a certain limit. The particles of the liquid in the steady flow continuous passes, so it's called streamlines. We act the water as the lines and imaginary lines. So the streamlines is the path difference of the particles of the liquid. Difference of the particles as a lines. And you have to know that streamlines is imaginary lines. If you want to talk about the turbulent, gases undergo turbulent, as in gases disperse or propagate in everywhere, but liquid have a steady flow. Density of the streamlines at the point is crossing the area of the water flow. If it has a lot of particles at a small area, so it's high density. If it has a small number of particles at a large area, so small density. Parts of streamlines, they are virtual, don't intersect as they are parallel, tangent to the walls. density of the streamline express the velocity, high density, high velocity, low density, low velocity. They become near at a point of high velocity because they are too dense, and they keep apart away from the point of the low velocity. Continuous steady flow, continuous of the steady flow as the volume rate of flow and the mass rate of flow. The mass rate and volume rate is the rate with time. They are continuous due to the velocity of the liquid. Conditions of the steady flow: the liquid fill the tube completely. To make a steady flow, the liquid have to fill the tube completely. Quantity of the liquid is constant, entering or outing. The velocity of the liquid at each point independent on the time, and the flow is no vortex motion, as it's not turbulent. Vortex as an eddy or windy. So you have to know the volume rate of flow. Rate is something about over time. So volume rate of flow, Q volume over time. Its unit is meter cube over second. Mass rate of flow is mass over time. The unit kilogram per second. Volume rate of flow is also known as area by velocity. So by substituting the volume by cross multiplication, making a quantity of volume rate of flow by time, and substituting quantity of flow of volume by area by velocity, so the volume will be area by velocity by time. On the other hand, mass rate of volume is quantity of mass, or mass rate of volume, mass over time, so the unit kilogram per second. By substituting in mass by cross multiplication, mass is quantity of rate of mass by time, and you have to know that the quantity of mass is density by quantity of volume. Density by quantity of volume, as in mass is density by volume. Mass by substituting quantity of volume by area by velocity, so quantity of mass is area, density by area by velocity. So the mass is density area by velocity by time. You have to know that the continuous passing of the liquid from the two sides of a tube, it's called a continuity equation. You have to know that the cross-section area is different from the entering and the outing, and also it's a continuity path motion, because the quantity of the mass entering equal to the quantity of a mass out from the other side. If you know that the quantity of a mass at area 1 is area 1 by velocity 1 by density, and the quantity of mass at area 2 is area 2 by velocity 2 by density, so by cancelling density with density, so area 1 by velocity 1 will equate with area 2 by the velocity 2, which is known as continuity equation. So V1 over V2 will equate with A2 over A1, which we have to know that they are inverse proportional to its other. So by increasing the area, velocity decrease, or decreasing the velocity, area increase. You have to know that the quantity of liquid may be branched into several branches. So you have to know that the quantity of volume is discrete or divided into several branches. A quantity of volume total will equate with quantity of volume 1 plus quantity of volume 2 plus quantity of volume 3. So area by velocity total equal to area by velocity 1, area by velocity 2, area by velocity 3. If they are branches are equal, so area by velocity total will equate with n, which is number of branches, by area 1 and V1 of each branch. Viscosity. You have to know that the liquid has a viscosity, which is property of resistance or friction. If you're talking about viscosity, you have to know the example of honey and water. Honey is too viscous, but water is low viscous than honey. Water is high viscous toward oil. So you have to know that the viscosity property of resistance of the liquid with layers. Explaining the viscosity, imagine layers of liquid trapped between two plates, one below them and the other is upper them, and by moving the first plate it will affect the second plate if the distance between the two plates is low, but if the distance is large there is no effect on the other plate. So you have to know that the force of the viscosity will directly proportional with the area and the velocity, and inversely proportional to the distance between the two plates or the 2 points that you want to calculate the viscosity by taking a constant which is coefficient of viscosity. So the force will equate with coefficient of viscosity by area by velocity over distance. So the coefficient of viscosity will equate to force by distance over area by velocity. Coefficient of viscosity, tangential force, which is then tangential force on unit area. And you have to know that the viscosity is used on lubrication to reduce the heat generated by friction or protect the machines, and also it's used in economy of the fuel consumption. So you have to riding your car at a small velocity, as it will consume fewer or lower economic fuel. That you have to know that the viscosity is too important in our life. Thank you for listening.